Okay, so we're getting started with the CHEM 107 Exam 1 review. Thank you all for attending today's session. So I'm going over the practice exam. This exam is embedded on Canvas, and what we're going to do is we're going to work through the practice exam together. I really encourage you to, after we've gone over this practice exam, yes, it is recorded. Yep. So I'm recording the screen capture. So as we go over the practice exam, we'll propose our responses and we'll talk about each question. So in the first case, we're asked to classify the following as a physical or chemical change. So let's read through the question and let's see what we can see. So when limestone is placed in acid, bubbles form. Okay, so what is this an indication of? The formation of bubbles. What does that tell us? What are we making?
Oh no.
So if we're generating bubbles, that's a sign that we're generating a product. And we're generating a new chemical species with slightly different both physical and chemical properties. So when limestone is placed in acid and you observe the evolution of gas, that's one of the signposts that we have a reaction. And as a result, because this looks like a chemical reaction, we can view this as a chemical change. Does that make sense? So remember, generation of gas, evolution of heat, production of a solid product, and a change in the observable appearance and color of your reaction mixture are all key signposts that you're dealing with likely a chemical change. So let's keep going now. And let's classify the following as a physical or chemical change. So we see when water from the ocean evaporates, sodium chloride crystals are left behind. What does evaporation remind us of? Is that a physical or chemical?
Physical.
Yep, exactly right. Yep, so this would be a physical change. Let's look at the third example, ice melts. So melting, would we consider that a physical or chemical change?
Physical.
Yep, exactly right. Okay, perfect. So phase changes, physical changes, chemical reactions are chemical changes. Do these first three questions make sense to everyone? Perfect. So let's clear this first batch of drawings and let's look at the next set. So we're asked to classify the following as physical or chemical properties. Potassium reacts violently with water. So we see the react keyword. Reactions indicate physical or chemical. When we see the keyword,
Chemical.
yep, exactly right. So this would be a chemical property. Lead is more dense than sulfur, so density.
Physical.
Yes, it's physical. And the reason for that is we can observe density without changing the chemical composition of the matter that we're observing. You can measure the mass and volume of a sample without changing its chemical identity. So density is a physical property. Okay. Any questions on these two examples? Does this make sense so far?
Yes.
Perfect. So allow me to clear and we'll scroll down. When we have to do a calculation heavy problem, I will switch over to the whiteboard. But for some of these problems, I find it's easier rather than copying and pasting them individually to discuss them in the module itself. So question 6, lithium chloride dissolves readily in water. Dissolves, what does that tell us? So dissolves, what is that keyword? Physical. Yep, exactly right. Solubility is a physical property because all we're doing is going from the solid state to the aqueous state. Does this make sense to everyone so far? Does this make sense to everyone so far?
Yes.
Perfect, perfect. So, continuing on, we're asked to classify the following. We're classifying matter now as a homogeneous mixture, heterogeneous mixture, or pure substance. So we see NaOH aqueous. What does this aqueous symbol tell us? What does this aqueous symbol tell us?
Homogeneous.
Yes, it tells us it's dissolved in water, which indicates that we have a homogeneous mixture. Exactly right, exactly right.
But I also think it's pure substance.
So the main thing about the aqueous symbol is that it implies that the compound is by definition dissolved in water. And because it's dissolved in water, inherently there must be multiple components in our mixture. If it was a solid symbol, then yes, it would be considered a pure substance. That is correct. The main reason why the aqueous symbol is given such a unique distinction has to do with it not only implies that the sample is dissolved in water, but as we may talk about a little bit later on in the class, the aqueous symbol also for ionic compounds is indicating that the ionic compound is dissociated into its component ions. Does that make sense? Perfect.
Why is not the pure NaOH? Why is not the pure substance?
If it was just NaOH solid, it would be. This is a pure substance.
Got you. Thank you.
But since it's aqueous, it's mixed, it's dissolved with water. And that's what the aqueous symbol is partially implying. Perfect. So let's look at this next example. And in this case, we're asked to classify the following as a homogeneous mixture, heterogeneous mixture, or pure substance. So CO2 gas, that is a compound. And are compounds considered pure substances?
Yes.
Yes, so this would be a pure substance.
But why this one you can't call it a homogeneous or mixture?
Because in CO2 gas, the only component is carbon dioxide. There's no other component. While in the aqueous example, if we looked, for example, at NaOH aqueous, it implies that we have sodium hydroxide and it's dissolved in water. So we have multiple unique pure substances mixed together when we have an aqueous species. While if it's in the gas phase, solid phase, or in the liquid phase, the only component is just our single pure substance. Does that make sense?
Yes.
Perfect. So let's look at another example. So we have lead chloride solid in H2O. And I like to draw a picture of this. So we have our lead chloride solid, and we have a layer of water above. So does this look homogeneous or heterogeneous?
Hetero.
Yep, exactly right. This is a heterogeneous mixture because there's a clear separation in phase and we have two or more components.
But what if we don't know how to draw this picture? Then how do we determine?
Yes. So looking at the state symbols, do you notice how the state symbols are different for our two compounds?
Yes, different.
So anytime we have a difference in state symbol, that implies that we have a separation of phase and a heterogeneous mixture.
So there are no exceptions They have different state, but then they like probably dissolve or something.
The only exception would be if it has the aqueous symbol. So like NaCl aqueous and water would be homogeneous because aqueous is dissolved in water. That's the
Okay.
only exception. Does that make sense?
Yes.
Perfect. May I clear this discussion so we can keep moving through?
Yes.
Perfect. So continuing on now, we're asked to classify the following as a compound, element, or mixture. So a substance containing atoms of two or more different elements chemically bonded. What? Yep, compound, exactly right. That's a textbook compound. Next, we're asked to classify the following as a compound, element, or mixture. So O3 in the gas phase.
Element.
Element, exactly right. Because even though we have multiple atoms bonded together, they're all of the same element. This is known as ozone, which is a form of oxygen. Or, well, more correctly, it's an allotrope of oxygen. Do these two examples make sense?
Yes.
Perfect. So let's clear and let's keep moving through. So next we're asked to classify the following as a compound, element, or mixture. So a sample containing copper and zinc atoms where the copper and zinc are not chemically bonded. So why is that not portion of our definition really important? What do we call a sample that has two or more pure substances that are not chemically bonded? What do we call that?
Mixture.
Yep, exactly right. Does that make sense?
Yes.
Perfect. And now for the last classification example, we'll classify the following as a compound, element, or mixture. So looking at
Element.
sulfur, it's definitely an element. If you're writing out the formula for sulfur, it would be S8 solid. Do these examples make sense to everyone?
Yes.
Perfect. So let's clear and let's keep going. So in this case, we're asked to fill in the blanks. So given a small amount of information, we're asked to fill in the blanks for the following problem. So we're given just iodine, and we're asked to figure out the symbol, state, formula, and fill in the rest of the blanks. So iodine. So looking at iodine in the periodic table, what is the symbol for iodine?
I.
I, okay, perfect. Okay, what is the state at room temperature? So iodine in general.
Solid.
Yep. Generally, if you need to take a guess, it's overwhelmingly going to be a solid, especially as you go down the periodic table. What is the formula of iodine, which is a
I.
7? What was that?
Is it I?
So it's a 7A element and a halogen, and those elements like to form diatomic molecules. So this would be I2. Does that make sense?
Yes.
This was in the chapter 1 notes and as well as the chapter 2 notes on chemical formulas of common elements.
Then we just type I2, but
Yep.
our 2 is not like yours.
That's fine. I have Canvas set up so it'll accept this entry.
Okay.
I'll also be grading all of these by hand as well. So I can check, and if there are any scoring errors, I'll make sure to correct them. So thinking about iodine, is it a metal, non-metal, metalloid, or noble gas?
Non-metal.
Yep, exactly right. It's on the right-hand side of the periodic table, which are where our non-metals typically are present. Okay, thinking about iodine for its period number, what row is iodine present in? If you look in the periodic table,
5.
yep, exactly right. So we just enter period number 5. If we look at iodine's symbol and the panel in the periodic table, its atomic number would be 53. That's a number above our atomic symbol. And what's the group name or group number for iodine?
7A.
Yep, 7A. But since the problem asks you to write the group name, if there is a name, the group name would be a halogen. Exactly right. Does this type of problem make sense? Does this fill in the blank problem make sense in terms of how to answer it in Canvas?
Yes.
Perfect. And of course, if there are any questions, don't be shy to type them in the chat. And I can read the chat and respond to the questions throughout this review session. Even if you're a student from another section, I'll be more than happy to answer and address your questions as well during this session. So let me clear these drawings and let's move on to the next fill in the blank. So this time we're given a little bit less information, but at the same time we're given a lot of information. So we know that the period number is 2 and we have an alkaline earth metal. So we're in the second row, and what column are alkaline earth metals present?
Beryllium.
What was that?
Beryllium.
Yes, this one would be beryllium. Yeah, the group number would be 2A, and if we find the second row in the second column, we'd find beryllium. Exactly right. And beryllium, if we look at its atomic symbol, has an atomic number of 4. Its symbol is Be, and its name is beryllium. The state at room temperature. What would you guess would be the state for beryllium?
Solid.
Yep, it's a metal, so it's overwhelmingly going to be a solid. Additionally, what else do we know about it? What else can we figure out? What else can we figure out? In terms of the chemical formula, we know that it's a solid. Metals, are they generally atomic or polyatomic? Do we see one atom or multiple atoms as part of the formula for a metal?
Oh, polyatomic?
For metals?
Oh.
What would we expect the formula for beryllium to be?
Don't know.
So in general, metals are atomic. They like to exist as their most stable chemical formula as atomic species. So the formula for beryllium would just be Be solid. Metals and noble gases are atomic species, and the chemical formulas of common elements are found in the chapter 1 and chapter 2 notes. Does that make sense?
Yes.
Perfect. And as we've established, as we see that it's an alkaline earth metal, it clearly is a metal. Does this example make sense from the practice exam?
Yes.
Perfect. So allow me to clear this and move on to the next portion. So looking at this example, we're given that our species has an atomic number of 12, and we have an alkaline earth metal. What element has an atomic number of 12?
Magnesium.
Yep, exactly right. So we enter the symbol for magnesium, Mg. We write the name. Okay, magnesium being a metal, what is its physical state going to be at room temperature?
Solid.
Yep, exactly right. And then its formula, will it be atomic or polyatomic if it's a metal?
Atomic?
Yep, exactly right. So its formula would just be magnesium solid. It clearly is a metal, right? It says so in the group name. And what is the period number? What row is magnesium
2.
found?
3.
3.
3. Yep, perfect. Does this make sense to everyone?
Yes.
Any questions?
When I write the chemical formula, I just write the Mg. I didn't write the solid.
That's more than okay. I'm mainly looking that you clearly indicate the number of atoms in the formula.
Okay.
Any questions?
Oh, not yet.
Responding to a student question in the chat. So let's look at this next example. So in this case, we're given this one has an error. So I provided you that the atomic number is 35, and I'd like you to tell me what element has an atomic number of 35.
Bromine.
Bromine, exactly right, exactly right. So then we fill in the symbol for bromine. So we know the name is bromine. What is the state for bromine at room temperature?
Liquid.
Yep, exactly right. It's one of our few exceptions. So we can say liquid or L. And bromine, before we talk about the formula, what is the group name for bromine? What group is bromine found in?
Halogen.
Yep, exactly right. And as we discussed previously, are halogens, are they monoatomic, diatomic, or polyatomic?
Diatomic.
Yep, exactly right. So the formula for bromine would be Br2. So is bromine a metal, non-metal, metalloid, or noble gas?
Non-metal.
Yep, exactly right. It's a non-metal. Its period number. So looking at the row that bromine is found in, what row is bromine found?
4.
4. Okay, let's check the periodic table just to be sure. I'm just going to pull up my copy of the periodic table just to make sure. So looking for bromine, yep, it's in the 4th row. Perfect. So we enter the period number of 4. Exactly right. Does this example make sense? So let's keep going now. And of course, if you have any questions during this exam review, don't be shy to ask in the chat or verbally, and I'd be happy to get your questions addressed. We're working through the Exam 1 practice exam on Canvas. So let's keep going with this. So we're asked to fill in for the symbol He, which is known as helium. So thinking about helium, first and foremost, what is the atomic number for helium? What is the atomic number?
2.
2. Yep, exactly right. So we have an atomic number of 2. Okay, so continuing on with this, what's the group name for helium?
Noble gas.
Yep, exactly right. It's a group 8A element, otherwise known as a noble gas. Now, the reason why this is important is as it is a noble gas, what does that tell us about the physical state? What's the physical state of helium at room temperature?
Gas.
Gas, exactly right, exactly right. So then, noble gases, are they typically monoatomic, diatomic, or polyatomic? Do noble gases like to bond with things?
Mono.
They're monoatomic, exactly right. Noble gases would rather exist as atomic species rather than form chemical bonds. For our metal, non-metal, metalloid, or noble gas, that one's pretty straightforward. It's a noble gas. You can also say that it's a non-metal. That's also a reasonable answer because it is in fact a non-metal. And then the period number, if we look at helium in the periodic table, it's in the first row. So it would be period number of 1. Does this example make sense to everyone?
Yes.
Perfect. Okay, so let's keep going with this example. So the next question we're asked to address is from the earlier questions. Let's indicate 2 elements in the table that would have similar properties and reactivity. So what is that asking for? Elements with similar properties and reactivity, what do they have the same? They're in the same what?
Group number.
Yep. So we want 2 elements with the same group. So what 2 elements from the earlier table are in the same group?
Bromine iodine.
Yep, exactly right. Perfect. Because they're both halogens. They're both group 7A elements. Does this make sense? Perfect. So let's keep going now. So we're asked to complete the first row in the following table. So given the isotope symbol, such as phosphorus 33, we're asked to calculate the number of protons, the number of neutrons, and the number of electrons. So first things first, looking at phosphorus. What is phosphorus's atomic number?
15.
Not the atomic mass, but the atomic number. In the periodic table, what is the number right
15?
above 15? Yep. So then we have 15 protons. This number above phosphorus 33 is the mass number. And we know the mass number is equal to the number of protons plus the number of neutrons. So then, solving for the number of neutrons, we get our mass number. One moment.